Okay, we got a little table here, and it looks like we've got x values, we got f of x values, g of x values, and then we have their derivatives at that location as well. And so whenever I see this stuff here, I know that they really just want me to use all of the chain rule, quotient rule, product rule, constant rule, all that stuff. Okay, so I just want to be able to execute the derivatives of these very carefully and then plug in numbers for each. I would not say it's not dissimilar from this guy. Okay, it's kind of like this guy. All right, so let's look here. If I wanted to take I want the derivative of h at 2. Okay, so I'll be targeting here, but it looks like h is defined in terms of f of x. So if I want h prime, okay, I've got to take the derivative of f of x. Okay, but the 2 stays there. Okay, so now if I want this guy, okay, 2, then I have to do that right there. Okay, and this is a plug and chug situation. What is the derivative of f prime 2? F prime 2 is 1/3. So it looks like my answer is 2/3. Okay. Here, if I want the derivative of of the derivative of m at 3, okay, looks like the derivative, m is defined by g of x as it has to be. Okay, all these functions have to be defined in terms of f and g because that's what we have the table of. So if I did this, well, that's easy. Okay, we take the derivative of those guys separately because they are just different terms. Okay, so if I want this guy of 3, I'm going to plug in this. Okay, and that's going to give me f prime of 3, which is 2 pi, and then g prime of 3, which is 5, and it looks like we just subtract them. Okay, so whatever 2 pi minus 5 is, that's our final answer. So what is that? It'd be 1.28. Okay, so now we got two functions being multiplied to each other. So if I want the derivative of s, okay, I got to take the derivative of the first guy, not the second, plus, don't take the derivative of the first guy, but take the derivative of the second. That's the product rule. So if I want s prime of 3, okay, it looks like I've got this action going right here. Okay, and this is how it's similar to the other problem here. F prime at 3 is 2 pi, okay, times g of 3, which is -4, plus f of 3. F of 3 is 3, and then g prime of 3 is 5. Okay, so it looks like we got -8 pi plus 15, and -8 pi plus 15 is just -8 pi plus 15. Okay. All right, now we get the quotient rule, and the quotient rule says that we're going to plug in a 2 into here. So let's take the derivative. Now I'm starting to get the flow here. So I take the derivative of the first, but not the denominator. Okay. Then I subtract. Then I don't take the derivative of the first, but I take the derivative of the denominator here, all over, plugging in 2, but we're going to square this guy. Okay? So what I did is I did this step, but I did it immediately. I'm just plugging in a 2. Okay. So what does this equal? Let's see. F prime of 2 is 1/3. Times g of 2, which is 2, minus f of 2, which is 8, and then g prime of 2 is -3, all over g of 2 is 2, and that's squared, so that's 4. Okay, so g prime of 2 is 2, and we will square him, so he's 4. So what do we get? We get 2/3 plus 24 over 4. Okay, well, let's see. That's going to be 2 over 12. That's 1/6 plus 6. So that looks like it's 6 1/6, or 37 over 6. Whoops. Okay. So I just kind of did that quickly. You can kind of vouch for that, and if you think I messed up on that, let me know, but I got a feeling that I'm right. Okay, we got a function in a function. That's the chain rule, because you got a function in a function. So let's go ahead and plug in a 2 here, because we do need the derivative of a. So that equals f prime of g of 2 times g prime of 2. Okay, so let's figure out what g of 2 is first. G of 2 is 2. Okay, now that means I need to find f prime of 2 times g prime of 2. Okay, so it just turns out that g of 2 actually is 2. So now let's find the derivative there, and that's 1/3 again. Okay, same numbers popping up, just in different context. And then g prime of 2 is actually -3. So times -3, and that's going to give us -1. Okay. All right, we're going to plug in a 2 here for this derivative. We're going to rewrite this guy, f of x, but we're going to make him go to the half power. Okay, so now we're going to have 1/2, and then we're going to drop him a degree, and then multiply by the derivative of f of x. Okay, because the square root forces us to take that square root function derivative first. Okay, and then we will multiply by that. Now I'm going to throw in a 2 now into both of those. Okay, because we are putting in a 2. So what is f of 2? F of 2 is actually 8. Okay. So what is 8 to the -1/2 power? Let me just double check that, because I'm not feeling that. But that is correct. Okay, so we've got 1/2 radical 8 times the derivative of 1/3. Okay, so I'm getting 1/6 radical 8. And we can take a 2 out of there, so 1/12 radical 2. Okay, that's fine, but that's better. Okay. All right, moving along. I don't know if I can squeeze all this in one video, maybe. Okay, so now we've got g to the second power, but he's negative, so let's actually rewrite this guy. Okay. So I don't even like that, because it feels like it's an inverse. So let's do this. G of x to the -2nd power. Okay, and then we're going to pop in a 3 in just a minute, but let's go ahead and get this guy, -2, and then g of x, and then that's going to be raised, though, to the -3rd power, and then we're going to multiply by whatever g of x is as a derivative. Okay. So this is the chain rule. We don't know what g of x is, but we'll take the derivative of the outermost function first. Then we will take the derivative of the innermost function here. So we're going to plug in a 2 there. So 2, g of 2 actually is 2. Okay. So 2 to the -3rd would be -2 times 1/8 times the derivative there, which is -3. Okay. So it looks like we'll get a positive 6/8. Which equals 3/4. Okay, so 3/4 is our answer. Okay, so now moving along, we're going to take the derivative now of u at 2. So we're going to have chain rule. Okay, so take the derivative of the first function, which is just himself, times the derivative of the innermost function. We are going to plug in a 2 there, so u prime of 2 equals e to the f of 2 times f prime of 2. Okay, what is f of 2? F of 2 is 8, so we've got e to the 8th, and then the derivative there is 1/3 times 1/3. So it looks like we got e to the 8 over 3. Nobody said these numbers had to be pretty or nice. They just are what they are. All right, now this is a curveball because they're using the limit definition. If you remember, as x is going towards 0, that's actually a typo. Do you know that they actually should have x? That x should be an h. Okay, so that's kind of interesting there. What they're doing here is they want the derivative of g at 3, and the derivative right here is actually 5. So the answer to this guy is 5. Okay, now why do I know that? Because they plugged in an x value of 3, because the formula should be x plus h minus g of x over h. But because they plugged in a 3, we now know they want to plug in a 3, and they're going to go straight to the derivative. Okay, so didn't have to do any math there as long as you recognize that this was the definition of a derivative. Okay, now we got some action going here. We're going to go ahead and find the derivative here, q, and it's going to be negative sine of whatever's on the inside. Okay, that is my dog drinking water. And he drinks it like he's never had water before every single time. So just putting that out there. Okay, so now derivative of the outermost function is going to be negative sine, and then we take the derivative here, which is just going to be pi f prime. The 2 goes into both of these guys, so negative sine of pi f of 2 times pi times f prime of 2. Okay? Alright, let's figure out what f prime of 2 is first. That's 8. So this guy is negative sine of 8 pi. Okay, we'll figure him out in a second. And then f prime of 2 is, I believe, yep, 1/3. So we're going to get times pi over 3. Okay, that's 1/3. 1/3 times pi is just pi over 3. So the sine of 8 pi is actually 0, because we're going to spin around the unit circle 4 times, and we'll actually get a y-coordinate of 0. So really, this is going to be 0 times pi over 3. Oh, okay, great. That's actually 0. So this whole thing ended up being 0. Okay, and I will stop right there.